Okay, so I'm here with Sean,
Hmm.
and Sean is going to tell us about his project on computer vision.
Yeah.
And when he proposed the project, I said computer vision is not computer
Yeah,
graphics.
definitely.
And I still believe computer vision is not computer graphics, but we decided to add it anyway because it's a very interesting topic. So here's the Project G landing page, and if we click on computer vision, we'll go to a Google Drive folder from Sean. And I've already downloaded the PDF of the prompt here, and we will talk about the prompt. But also, there is
Starter
a
code.
starter code. Good, thanks. That's a good way to phrase it. That is there, which is for Jupyter notebooks. And so Jupyter notebooks are a phenomenon. I know in my space, I look at scientific data, and people are very excited about using Jupyter notebooks to look at scientific data, meaning like physics data, simulated data, but it's used in a lot of places, right?
Yeah.
So Jupyter Notebook is also hot in the
Yeah.
computer vision area
Yep.
as well, right? And
Yep.
many other areas.
Yeah.
And so I've actually never installed it before. It's easy, it's free to download
Yeah,
Jupyter
it's
Notebook.
free. It's inside the application called Anaconda.
Yeah,
Yeah.
okay.
If you download the Anaconda, then you can have the Jupyter Notebook inside your computer.
And it's all Python based, correct?
Yeah, it's Python based.
Python based.
Yeah.
And so I think for many of our students, because they learn Python in their freshman year, they feel very comfortable with Python.
Yeah, sure. Yeah.
So we have not installed Jupyter Notebook here. Instead, it's possible to open it up and have it work as part of Chrome. That said, for me, it didn't work the first time. And Sean showed me that if I right-clicked and I went Open With, we actually went and found the possible apps and we connected it to Collaboratory. And so now my Chrome has learned that when I've got something that has the extension IPYNB, that it's part of Jupyter Notebook and I should open it up with Collaboratory. And so for you, if you go Open With and then it says connect more apps, then you can find the apps. And so then Sean found Collaboratory.
The very bottom?
Oh. It was the very bottom when
Yeah.
we didn't have it connected.
Yeah.
And so it was down in here somewhere and he connected it.
Yeah.
And so now when we click on it, and click, because we've already clicked on it, and now it's here.
Mm-hmm.
And so now we're looking at this in Chrome.
Yeah.
So let's come back to this and just look at the prompt really quick.
Yep.
So it looks like we're doing the classic computer vision problem, which is it a cat? Right? That's the most classic computer vision problem because there's so many databases of cat pictures that are well annotated, right?
Yep.
So let's just look this over real quick. So excellent. There's an overview. What are you going to do? You're going to do some machine learning with convolutional neural networks. Yeah.
Actually, the concept here you do not need to know all of them. It's like if you want to understand what's inside the neural network, then you need to know all of this. But for this project, it's basically all you need to know is about the CNN, which is the convolutional neural network.
Yeah.
Yeah, you do not need to know really about the logistic regression or the backpropagation or the forward propagation.
Yeah, good. So and that's my understanding, but I'm going to repeat this. Mm-hmm. You don't need to understand machine learning. You're a machine learning user.
Just a part of
machine
learning.
And so how would they learn the part they need to know? Oh, so you've got it documented
because
here.
We will use the keras as the library, and then we will just call the functions inside the keras. So those functions will take care of some machine learning computation for you. So all you need to do is in the right place call the right function.
Okay.
That's all you need to do.
Very good. And it looks like there's a tutorial here so people can learn more as they need to go. And so for this is an 8-hour project. I already know the answer because we said that's an 8-hour. They should be 8-hour projects. But here you say yes, this is an 8-hour project for students.
Yeah, I think basically it's an 8-hour project, but I don't think you will spend all hours on the coding because the coding is very tiny. So basically, you will say I think you will for this.
I'm so vain. I'm sorry.
Tutorial. So maybe you should spend like 3 or 4 hours to understand what's the CNN, and then for the coding part, it's very easy as long as you understand what's going on.
Yeah, very good. And I think many of our other projects are the same way. It's a matter of learning some technology, and that's the majority of the time, and then implementing it's easy. And so someone that already knew about machine learning may do this in much less than 8 hours. That's fine, no problem. And someone that doesn't, this is intended to be an 8-hour project, including the learning.
Yeah.
So good. And so you've here documented the environment, and there's the starter code and the steps that they're to go through. So it says they're prepared data. Excellent. Looks like you've developed a really nice prompt. Thank you for that. I appreciate it. And then building the model and kind of taking them through step by step what they need to do to actually succeed. So that's great. And then there at the end it says our model's ready to go. Let's train it and see how well it can learn.
Sure.
So sounds really neat. I like I said, computer vision is not computer graphics, but we decided we'd still offer this 8-hour project. So, excellent. The prompt looks really nice. Is there anything here on the skeleton code you want to walk people through and discuss?
Yeah, actually, if this is the first time you use this notebook environment, which is the IPython environment, so basically you have some cells here, right? And the cells contain some code. So basically this is very different with your program file. It's like the notebook can be executed cell by cell, right? So basically you can just compile a part of your code and run it. So basically if you want to run this cell, what you can do is you can, the short key is the shift and the return. So you click this and this. No, it's not okay. Okay, so you can click this. Set running read only. Oh, is this read only right now? It said it's read only.
Perhaps it's because I'm running your version.
Yeah, maybe I should change the...
No, I don't think you should, because then people are going to overwrite your stuff. I think what this means is if we wanted to do this, and this is what the people at home would do, if they want to run in Chrome, they'd have to go and make a copy of this in their own personal space.
I think so.
Right, so I'm going to make a copy, and now it's in my drive. And so if we click on my drive, let's see, here's all my folders. This is the thing we just made.
Yep.
And so now I'm going to close the other one. And so here's our copy. And we'll just change its name to be, whoops, like that. And so now give it a try.
Okay.
And see.
So right now the first thing I want to do is you want to import those packages. Okay, so we will use that. So I think if you work it online, Google has provided all the packages, so you do not need to install this on your own computer. But if you do this project on your own computer locally, then you need to install all the packages before you run this cell. So to run this cell, what you can do is click the shift and the return button, and then this will run the shell. Let's see if it's work. Okay.
So I want to comment while we're waiting. You recommended that actually students install Jupyter Notebook and they install the packages. You think they'll have a better experience. And I had said, if it's possible to run through Chrome, installing software is sometimes hard. So it might be that the path for people is to try to install it because you think they'll have a better experience. And if they can do it easily, then great. And if not, then they try it here. And if it doesn't work here and you can't install it, you should not do this project, right? Because you could spend a long time trying to resolve that. So, okay, sorry to interrupt you. Keep going.
So if this you run the cell, and then you can see this, using TensorFlow backend, because the Keras is kind of like an interface, and then the backend we will use the TensorFlow to do our neural network. And then for this function, I provide this function to you, and then you can, through this function, you can load data. Okay, so the path of your data should be inside a folder called the dataset, and then you will have two H5 dataset. One is for training, one is for test.
Where are they? Where are those files?
Okay, so those files I provided as well on my Google Drive. So maybe we want to go back.
We'll probably have to make a copy of that as well.
Yeah.
So as we're doing this, I don't want to redo this video, so we're getting this video that is not perfectly optimized, but I think probably we're going to have to figure out how to do this.
Yeah, so at the very top, so here we have, I provided the dataset folder, so there are two H5 files.
Yeah, but then my guess is that this code here is assuming that it's in a directory called datasets, which is a subdirectory of my own drive.
Yeah.
So I'm going to have to make a copy over there.
Yeah.
And I think it'd be good. So I think we're going to stop here on running it.
Okay.
I think it'd be good if the prompt just kind of reflects a little how to do this. Make a copy of data sets,
Okay.
put it here, etc.
Okay.
So I think that we're probably done with the video for now, right? You know, you might. So I don't think we're going to be able to run anything more.
Yeah.
But if you want to walk through a little more code, probably the students would appreciate that. Is there anything more in
Okay.
the code you want to point out?
Basically, you just run this function, and then you call the function, and then you can call this function here in this cell to load the data inside this 5 variables, and then you can access those variables to access the actual data. And the one good thing about the Jupyter Notebook is that it can evaluate the data separately, so it can visualize the thing inside each variable. So all you need to do is do something like, okay, so you add a code here. So for example, if you want to see what's inside this variable, what you can do is you copy this variable here, and then you execute this cell, then it will visualize the data for you. Okay, so and then we want to do some reshape thing because the data is stored in the NumPy array. So that's the array provided by the NumPy by the NumPy package, and then because the shape is not right, so read the tutorial and also read the instruction to figure out what should be the correct shape, and use the reshape function inside the NumPy array to do the reshape to make sure the input shape is correct. Otherwise, your model cannot accept this input data. And then you want to make sure the Y data, which is the label data, to make it categorical. So this is also in the NumPy array. We have a function that could convert the Y value from a number into a categorical number. Okay, so this I also covered in the instruction, so you can look at it to see what's going on. And also here is the visualize of the X data, which is the train set X data here. So here you can change the number of the index to see each pictures. So I think in the train set we have like more than 200 pictures. So basically you can just try out different index number and see what the picture looks like. And then here is that, okay, so you also need to turn your X data into this type, float 32, and also map their value into range from 0 to 1. Okay, so right now, because the X train data will contain some data for the colors, right? So the color is from 0 to 255, and then you need to map those range of the value into this range, okay, from 0 to 1. And then
we're very comfortable with that mapping.
Yeah.
Our colors to 0 to 1 and then back to 255. We're used to such mapping.
Yep. And here is the place you build your model. Okay, so basically you want to keep adding some layers to your model and then make sure your model works. And here, after you build your model, you want to compile it. So here we will use the cross entropy as the loss function, and we use the item as the optimizer, and the matrix, we will use the accuracy as the way we evaluate our model. Okay, so this part you do not need to worry about what's the loss function, what's the optimizer. All you need to do is you go to file and then you compile. If there's no error, then you are good.
Excuse me.
Bless you.
Yeah, thank you.
And then you want to train your model. So basically, this is also provided. You just run this line here, and then you will see a progress bar.
I'm allergic to machine learning.
Okay. Yeah. So you will see a progress bar, and the iterations, number of iteration you can change here. So right now it will train your model 10 times. You can always change the number here and see if you train it more than 10, what will happen. Okay. So then during the training, you will see there are two things. One is called loss, one is called accuracy. So if you see during your training, your loss is decreasing and your accuracy is increasing, then that means your machine actually learned something. Then you are good. And then evaluate the value. So also execute this line, and this will print what's the accuracy of your model doing the prediction using the X test data, and then compare it with the correct answer, which is the Y test label, and then it will show what the percentage of the accuracy is. And here so here I call the predict function. This will take the text data set as the input, and then will predict the result based on this input. And then you can visualize your result. Okay, so basically here I just say, okay, so basically if the result, okay, so the value here is an integer between 0 and 1, and then here I just change it, translate it into English. It said if it's bigger than 0.5, then your prediction is that picture is a cat. If it's lower than 0.5, then your prediction is it's not a cat. And then you can also see the image of that input X. And here it will show what's the error, or the index of the mispredicted image. So basically, if you made a mistake at some picture, it will show the index here, and then you can visualize why this picture is not correct or not. Maybe it's too small, maybe it's too big. Yeah. Okay, so that's all the code.
Wow, very good. Well, let me just again say thank you. Even though this is a graphics class, I think people will appreciate having the opportunity to learn a little more about machine learning and computer vision. Looks like you put together a really nice prompt and skeleton code and a nice explanation here for everyone. So thank you. I appreciate it. And thanks for coming and doing the interview.
Yeah.
So, okay, very good. Bye, everyone.